All right, so I have some slides that you don't need to take notes on. You just have to kind of listen and watch, and there'll be some follow-up videos that you will take notes on. So I just want to first show you what a stem and leaf plot was. So a stem and leaf plot shows you an entire distribution of data. There should always be a key, so if you notice the key down here, you can see the 7 that comes from, let's say this 7 right here, that's the stem, and then a line which indicates the separation line, and then the 8 could be, let's say that 8 right there. So the key will tell you that that represents the number 78. So if you look at the 7, you've got a 2 for a leaf, an 8 for a leaf, an 8, and an 8. So each of these leaves go with the 7. So you've got a 72, a 78, a 78, and another 78. The next row you have an 84, 85, 87, 88, and 88. Now if you get up to the 10, if you have a 10 and you put a 0 on the end, that's 100, so you have two 100s. So this could maybe be distribution of test scores. You can say, oh, the highest grade was 100%, lowest grade was 49%. Looked like we had most of the tests were in, well, not most of the tests, but we had a lot in the 80% range. Very few, how many students failed the test? Just these 3 down here. So you can answer some quick questions about data when you see it in a stem and leaf plot. Here's another one. Don't worry about writing this down, but I just want to show you what a back-to-back plot looks like. So back-to-back plot allows you to compare 2 sets of data. So here we've got males on the left and females on the right. This stem and leaf plot is missing a key, so I'll go ahead and write one in. Let's say the 7/2 represents, I don't know, maybe it could be a decimal, 7.2. And so I just looked at this number down there. When you have a back-to-back plot, your 2 sets of data will share the stem in the middle. So if we look at what is this number right here, it's a 9, but you want to pair it up with its stem, that's going to be a 2.9. Let's see, this 2 with its stem is a 4.2. All right, now when you read the left side, if you notice, the smaller numbers are closer to the stem, and then they get bigger as you go out away from it. So if you have, let's say, this 6, remember the stem is always the first number you write down, so that is going to be a 5.6. This one right here, pair it with its stem, that's a 7.1. Not a 1.7, because the ones on the left, remember the stem is always the first number. All right, we're also going to take a look at histograms. You don't need to write this down because you'll do a histogram in a separate video, but a histogram shows a distribution of data. So in this case, we're talking heights of black cherry trees. Down here on the x-axis, you can see all the height ranges from 60 to 65, 65 to 70, 70 to 75, blah, 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 like that. All right, now the left or the y-axis tells us the frequency. It tells you how many trees fell in those intervals of heights. So how many trees were between 60 and 65 inches? You would look up and you'd say, oh, 3, because that went up to a 3. How many were between 70 and 75? So you go all the way up and you say, oh, yep, that was 8. Which range had the most number of trees? Well, right there, the tallest one, between 75 and 80. Which one had the least number of trees? Right there, between 85 and 90. So it's just basically a way to organize data, and it gives you a nice visual of what the data looks like.